So this question is actually now out of the syllabus. We no longer have to look at our collinear. Pardon me. Or is a line collinear? I'm pretty sure. So I'm not gonna go through that exactly. But what I do like about this question is just thinking about the way the gradients and the equations and the angles are all in the question. So we'll work through just to describe what's going on. Okay, so collinear means the 3 points are on the same line. So what you usually say is that you've got the same gradient. If that's A and that's B and that's C, you would say that MAB is the same as MBC and B is a common point. That's your usual finishing line. So what we'll do is we'll just look to see what the two gradients of these lines are. Just because I like the way that the question is. So let me just zoom out a tiny bit there. Yeah. So the first one, how do you know what the gradient of this line here is? Well, we have to rearrange it first. So I'm going to call that. So ABC are points. AB is parallel. So AB is parallel with that equation there. So it's kind of the same gradient as that one. So y plus root 3x equals 0 means y is equal to negative root 3x. Move that to the other side and plus 0. So there's no intercept. The gradient of that is therefore negative root 3 over 1, or whatever, you just say negative root 3, but just thinking about it for later on. So that's my gradient for line AB. When I'm looking at line BC, it makes an angle of 150 with a positive direction of the x-axis. So what that means is it's doing something like this, and there's my 150 degrees. Okay, so to get the gradient of that one, I need to use this angle. Okay, I need to use that angle to make my little triangle. So I know that angle in there is going to be 30 degrees, and I should know that m is equal to tan of theta. So my gradient is equal to tan of 30 degrees. So for that, you need to use your triangles, your little exact value triangles. So 1, 1, root 2, and that's 45. And the other one, these are my right angle triangles, so you've got a little right angle in there. This is root 3, 1 and 2. And I always remember the root 3 goes next to the 30. The 3's are so the 3's are together on that one. And this is 60 degrees. So tan of 30, tan is toa, so opposite over adjacent. So if that's 30 degrees, the opposite is this, and the adjacent is that. So that means the angle there, the m for this one, is negative 1 over root 3, because negative is going down this way. I just need to infer that from the sketch, and opposite over adjacent 1 over root 3. So they're both negative, but this one is 1 over root 3, whereas this one is negative root 3 over 1. So they're not collinear. They're not, not got the same gradient. But I just quite like that question because it makes you think a little bit about the gradients. And this is something that gets people a lot. Be careful when you're working out your angle here. You're not using 150. You're using 30 because you're looking at this triangle. Yeah, what triangle can I make from this 150? Nothing. To get a gradient, I need to know a height and a length. So it's that little triangle in there. Okay, and you should know that's negative going in that direction, positive going in this direction. So yeah, for this one you would get a mark for your two gradients. So root 3, negative root 3 gets you a point, absolutely. So I was tempted to change that into an angle, but yeah, you can just leave it as negative root 3, that's fine. And that one, you get another mark for this here. And then your statement, they don't have the same gradient, so they're not collinear. But I don't think that's in the course just now. So yeah, hope that's helpful.